So how many different laboratories?
More than 60 delegates and keynote speakers from global organizations working with or depending on lab analysis.
You can do a perfect job with perfect equipment, but if the sample is not representing the actual commodity that it's supposed to represent, then your analysis is worthless. In general, when we are talking about homogeneous cargoes, liquids, or very well-processed products, you don't have a lot of difficulties with the sampling. But natural products, and certainly cereals and oilseeds, they are not very homogeneous. They are, for some aspects of them, they are even very heterogeneous. Shipments, Panama vessels, 50,000 tons. I mean, 50,000 tons means 50 million kilograms. And from that 15 million kilogram, there is something like a 1 gram that at the end will be analyzed for protein determination. And protein determination is a determinating factor for the establishment of the contract price. What can be done is that at least the people involved in sampling, and then usually they are the GAFT and the FOSS superintendents, that they correctly act according to the existing sampling rules, and additionally that if specific parameters are requested for analysis, again I'm using the example of aflatoxin, then we should take more intensive sampling. We should do a more intensive sampling, and we should use a bigger sample size. A bigger sample size that then, when it arrives at the laboratory, is fully homogenized and to obtain a stable result. In the past, sampling was considered to be an easy topic. Now, with the fact that more contaminants are being analyzed for or looked for, sampling becomes much more critical, and our people are very well informed and guided to assure that the sample is taken, at least that it is fully representative of the cargo that it is representing.
What we are seeing is that it's now much more recognized that there are health beneficial effects in dietary fibers, so it's important in that way to know the amount of dietary fibers which you are having in your diet. And nowadays we see that it becomes much more clearly that different dietary fibers have different health beneficial effects. So you should not just eat enough fiber, but also you need an intake of various different types of fibers for a good beneficial effect. It depends on what you want to measure. If you apply the standard AOC methods, it is very classical what we are doing. Those methods require hardly any equipment. If you want to measure specific dietary fibers, as the adulterants from oats, it requires that you apply very specific enzymes in your analysis. If we look now to the new 2009.01 dietary fiber method, it is a very time-consuming method. If you do exactly according to the protocol as described by the AOC, it takes you about 3 days for one analysis. If you're doing, you can also do it in a series, then you do 20 samples in a series and you have 20 analyses in 3 days. But in my perspective, we should automate that method. Then the work can go on during nighttime at 16 hours a day. So it can be speeded up by automation, and that is where we are looking at, and we are hoping that companies like FOSS and other companies will also do an effort to automate the method in order to increase the sample throughput of the analysis.
We need both worlds, right? It's not possible sort of to do with the one without the other.
The problem with nitrogen-based analysis for determination of protein is that this is susceptible to adulterants. It is susceptible to other sources of nitrogen being added to the sample, and then you get a wrong impression of the protein content or the crude protein content. The response on the chemical analysis side was to use other schemes to differentiate between different nitrogen fractions. Yeah? These kinds of fractionation schemes actually are around for a number of different types of samples. Yeah? Of course, this takes longer time to make this, and it is more cumbersome to do this kind of things. Yeah? Fortunately, we have one solution already at hand. As I mentioned in my lecture, I regard NIR and also FTIR as nitrogen-based methods, as the calibrations and the validation of these calibrations is based on the original Kjeldahl or Dumas methods. So we can say this is also a nitrogen-based method. But on top of that, they give us the opportunity within seconds to analyze the spectral identity and see whether there are spectral anomalies. And this way identify this sample as not a normal sample. This sample contains some kind of adulterant. The spectroscopic methods are indirect methods that need to be calibrated against a reference method. And then also they need to be continuously validated against this method. So you must be very careful in selecting the reference method. Let's say I can, for certain type of samples, I can mix Dumas and Kjeldahl results and do not get the optimum precision out of it because I have a unnecessary variation in my calibration. Even worse, as I mentioned in the lecture, if I am tracing adulterations and have a lot of the adulterations already in my calibration sets, then this option is not valid, is not existent for me anymore. I must have a very clean data set with no adulterations, no adulterants in it, and able to see if some adulterant comes in.